Hi, this is Maeve and Julia's paper slide video introducing linear and exponential growth and decay. Linear growth. Sally is dog sitting. She is going to walk the dog 2 miles every hour. If this pattern continues, how far would she have walked if she walked 10 hours? Our explicit rule is y equals 2x. And our recursive rule is next equals now times 2. Our start is 0. Y equals 2x, so we put 10 in as our hours, and we got 20. Y equals 20. Y equals 2 times 7.5 is our how long would it take her to go 15 miles, and we guessed and checked that it would be 7.5 hours. This is our graph and table.
Look at the pink line messed up on the green table.
So we have our start as 0, and it goes all the way up to 8, which is 16.
So, exponential growth. 4 square feet of moss was planted in Josh's backyard. It grows by 15% each day. How much moss will there be in 4 weeks? When would there be 10 square feet? So the explicit rule is y equals 4, parentheses 1 plus 0.15, and to the power of x, but in this case it's 28 because 4 weeks. So to solve it, it would then be 4 times 1.15, because 1 plus 0.15 is 1.15, to the power of 28, and that will get you 200 times 26 feet, which would then get you 6.5 days for, hold on, I'm very confused.
Because we guessed and checked.
Yes, for the square feet, and then 4 weeks will get you something. So this is our graph and the table.
We started at 4, and our last number was 7 with 10.64. Moving on to linear decay. Matt has 200 gumballs. He eats 4 every hour. How many will he have left in 10 hours? Our explicit rule is y equals negative 4x plus 200. Our recursive rule is next equals now times negative 4. Our start is 200. Y equals negative 4x plus 200. And then that was our explicit rule, and then we replaced x with 10, so y equals negative 4 times 10 plus 200, and we got y equals 160, and so 160 gumballs. Our input-output is when would Matt have 100 gumballs, and we said he would have 100 gumballs after 25 hours. So our graph is showing this number of gumballs and the hours, and then our table is showing the start as 200 and the end value, which is 8, as 168.
Got kind of cut off. So lastly, our exponential decay. Billy bought a new Audi for $90,000. Each year, the car decreases by 9%. How much will the car cost in 9 years? When would the car be $30,000? So the explicit rule is y equals 90,000, parentheses 1 minus 0.09 to the power of x, or in this case 9, for 9 years. And the recursive rule is next equals now times 0.91, because 1 minus 0.09 is 0.91. And the start is 90,000. So to solve it, the first problem, it would be 90,000 to parentheses 1 minus 0.09 to the power of 9, and 1 minus 0.09 is 0.91, and 90,000 times 0.91 to the power of 9 is 38,513.68. So that's how much the car would cost in 9 years. And when the car would be $30,000 is you guess and check, and about 11.5 gets you to about $30,000. It's hard to get an exact amount, but around 11.5 is when you would have 30,000, or it would be 30,000. And here is our graph and the table starting with 0 at 90,000. So that is the end.